Welcome back to Let Us Learn to Lead video series on free open source software prepared by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form and GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to construct a similar triangle using SAS criteria, 2 sides and 1 included angle. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let us see what type of worksheet we are going to prepare. First, we will tell construction of similar triangle is criteria. Then we will tell the children that what is the meaning of this criteria. If two sides of one triangle is proportional to two sides of another triangle and the included angle in both are congruent, then the two triangles are similar. We'll start with a triangle now. Then we will try to construct another triangle similar to it by taking two sides AB, AC and then angle A. Then after that we will try to tell them that the corresponding angles are equal and the corresponding sides are proportional. What is the meaning of proportionality? AB by DE is always equal to BC by EF is equal to AC by EF. Then we will ask them to come and make changes in the original triangle. You can't make the changes in the triangle which you are drawn it similar to the first one. Now everywhere the angles are same and the proportionality is always that 0.5. Here I have taken one is 2 times the other. Therefore, it is always you are getting it as 0.5 everywhere you keep it. Well, let us try to make this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet. I have selected Geometry View. And in the options, rounding off to 0 decimal place, labeling of new points only. We will tell the children that what we are going to do. Similar triangles. SAS criteria. We will ask the children that what they mean by this SAS criteria. I think already I have explained. Always go for this navigation bar, which will always help you to explain them step by step. Okay, now already I have defined what do you mean by that. If two sides and in one triangle is proportional to two sides in another triangle and the included angle are congruent, then the two triangles are similar. We will explain it to the children and that can be displayed here also. Okay, the children can understand that what do you mean by that similar triangle and what do you mean by that SAS criteria also. Okay, well, now let us come back to construction of these triangles now. For that, let me take a segment or let me take a triangle A, very small one, AB and then C and then A. Okay, I have taken a very small triangle. We can expand it afterwards. Escape and then bring this A here and then bring this B here, bring this C here. Okay, what I will do is I will take this AB and AC. You can take any of them. Therefore, let me get the angles also, the name of the angle also. I want to have the angle in clockwise direction. Therefore, touch this B, touch this A and touch that C. You will get that angle A. That is alpha. Now, I want to take this AB, AC. Well, let me see what is that AB. Therefore, object property, I will show only the label and AC also I will show only the label. I don't want the value of it because the value varies. But the variables are B and C here and the angle is alpha. When I move it, C changes, B changes, alpha changes and so on. You know it. Okay. Well. Now let me try to construct another triangle now. For that, let me go to this segment with the given length. It should be very important. Just to touch it, it will ask you what length you want. Now I want a length proportional to AB. Therefore, let me type 2. Okay. Then you can have multiplication symbol or you can have the star symbol also so that it will get multiplied. Therefore, 2 star then small c. Therefore, I am just clicking OK. Now when I move this, okay, escape. When I move this, you see that DE also is moving. Okay, now I want angle now. Angle should be congruent. So let me take the angle now. Angle with the given size. I will touch this E. I will touch this B. It will ask what angle you want. Now I don't want an angle alpha because when I changes it should change. Therefore alpha. Therefore I am putting it OK. Now let me go for this ray and then get this ray for this angle. Okay. Escape. Again this E dash I don't want. Therefore I will show the object. When you click, it will go now. Now I have to get that C now. That is DEF. Okay. DEF, I got it. Now F I want. For that, this I have taken it as a proportionality of 2 times. But here also I have to take 2 times of B. For that, once again, take the circle. Circle with center and radius. Click it. Simply touch it. It will ask what radius you want. I want 2 times B. I want 2 times B. Click OK. It is touching at a point now. I will go for the point of intersection. I am simply touching this circle and this line. Have I got that F now? Okay. Therefore I got that F now. Okay. It is 2 times of this B now. Well, now I will go to this polygon. Let me complete this D, E, F and then D. Now I don't want things which have helped me out now. Or I can hide it. Right click, show the object. Again right click and show the object. It will go now. Anything else required now? Okay. Now all are got it. You got everything now. Now you claim that this ABC is similar to DEF. How to show it? Or you can write it here from the symbols. You can have the symbol for a triangle. The triangle symbol is over here. So for triangle ABC, capital ABC. Now in the symbol, you select whether that similar symbol is there. The similar symbol will be in the here over here. This is the similar symbol. Okay, similar to triangle DEF. Okay, now how you claim it that these two are similar? Okay, now we have to go for that corresponding parts of the similar triangle. You claim that the angles are equal. Okay, first claim I make that angles are equal. Let me check whether the angles are equal now. I have to go for the remaining angles for the first triangle and also for the second triangle. Okay, I'm go for this angle. I go in clockwise direction. 1, 2, 3. Again C, B and A. Well, I got these angles over here. One is 70, another is 54. Let us see whether the same thing happens in the second triangle also. Go to this angle. B, F and E. Oh, 70 I got. Once again, touch F, touch E and then touch D. Oh, you got that 54 also. Okay, now when I move this, you are watching 42, 68, 37, 37, 106. Okay, well, now the angles are equal. Now you can tell the children that what angles are equal. For that you can go to the symbol. The angle symbol is over here. I will write only one of them. You can tell them the remaining angles. Angle A is equal to angle D. I will write only one of them. Now you can write the remaining. Both alpha and beta. So from the object, you can select this alpha and then click OK. For whenever I am moving it, whenever alpha changes, you can see that also changes there. 71, 71, 42, 42, like that. Similarly, you can write angle delta is equal to angle eta, then angle gamma is equal to angle phi. Okay, the same way you can write it. Angle C is equal to angle F and angle B is equal to angle E and so on. Okay, well. Now, let us take the next property, that is the sides are proportional. Okay, what is the meaning of the sides are proportional? You have to tell the children what is the meaning of it. For that, again, I am writing it very clearly. Go to this latex formula. In that latex formula, you are having fraction over here. In the fraction, in place of A, you write the first side. That is, you write AB. What will be the side from the second one? It will be DE is equal to, once again in the latex formula, roots and function A by B. Remove this A and then type the next one BC. The corresponding side you remove it and then you write EF is equal to, it will come very perfect. Latex formula, roots and function A by B. Once again remove this A and write AC. Here its corresponding side will be DF. Okay, DF. Okay, you can click OK. Now it is coming over here. Now what you can do now, here you see we don't know the length now, therefore let us do it now. Here simply show the label. Here also come back and then click it and then show the label. Then here you come and click it and then show the label. Here come and click it and then type only the show the label. Okay, I think the whole thing is selected. Be careful with that. Only the segment should be selected. You see, segment is selected, show the label. Okay, now it is D1, D underscore 1. Please don't get confused with that. Okay, because it is taking it in order. Okay, now how to tell that the sides are proportional? It's very simple. C by F. Therefore, go to this text. Okay, then you type over here latex formula, roots and function A by B. In place of A, delete it. From the object, you select C. From the object, you select C. And in place of B, you select F. You have to select F. Okay, is equal to. What is the second one? The second one should be A by, I think I will just show you, A upon D1. Therefore, once again, latex formula, A by B. Remove this A. In that place, you have the object as small a. Here in place of B, very simple, latex formula is not a very tough one. It is D1. Okay, okay, is equal to, once again, go to the next one, that is B upon E. Therefore, latex formula, A by B. Then here you have to replace it by the object B, because that will be going on changing by, again from the object you select E. Okay, well, click OK. Now remember, you have selected up to 1 decimal place. Rounding off to 1 decimal place, normally automatically it will come. Always it will be 0.5, 0.5. Okay, now you want to tell them that actually what is the value of it. So go to the graph, go to the graphing, or here also you can do it in the geometry. In that view, go to input bar. Okay, in the input bar, you see what are the things it has been used now. You see here, you should be very careful. You should be very careful with what are the alphabets used by GeoGebra. It has used the alphabet up to D, G. Okay, you have to be very careful. F is used, therefore ABC is used. Okay, it has used up to G. But you don't have that H. Therefore, what you can do now is, I will go to geometry now. In the input bar, go to the view, go to this input bar. In the input bar, you type H is equal to, okay, small h is equal to, you want the value of C upon F. Okay, just press enter. You see what you are getting. Let us see. I am just showing you graphing the value of H. You see, it is coming as 0.5. Suppose if you are interested, suppose you want to tell, sir, I am highly interested to know the value of the remaining also. That is, I want to know, for example, I is equal to, I am just introducing a new variable now, A upon D1, D underscore 1. D1 will be D underscore 1. You see, that also 0.5. Okay, now J is equal to the next one, B upon E. That also I am entering. You see, that also we are getting 0.5. What is the meaning of it? All these proportions are the same now. Or you can now type it also here. Text also you can now. What is the new things you have got now? You have introduced now H, okay, is equal to, all are same. I think you can have the same thing. I is equal to, now you can have the same thing here also, J. Okay, you can put it over here. Therefore, now you have proved that the angles are equal and the sides are proportional. The sides are proportional because I have taken the C, for example, B and E, the side AC and DF. DF is 2 times. Therefore, you are getting it as 0.5. If you have DE by AB like that, if you have, then you will have 2, 2, 2 everywhere. Now you can move it. This only can be moved. You can move it and then tell at any spot. They can spot out that the angles are equal and the sides are proportional. Therefore, using SAS criteria, we have constructed 2 triangles, those who are similar to each other, and we are getting a plenty of triangles to check whether the property of the corresponding parts of similar triangle works out. Thank you. Let us learn to lead.